Our interest in the ATREX mission is to try to understand the chemical composition of air in the region where the Global Hawk flies, and this is the upper troposphere, and particularly the tropical upper troposphere. So we look at air, the composition of air at different altitudes to understand what happens to the chemical compounds in the air, how they're degraded, and also how they're transported from the upper troposphere through a layer of the atmosphere called the tropical tropopause layer, and ultimately into the stratosphere, where some of the types of compounds that we look at participate in chemical ozone destruction in the stratosphere. And we do this by taking air and compressing it into air samples, which we bring back to the laboratory and analyze the trace gas composition in the air that we've collected.
And the way that we sample is by taking air on the different layers of the atmosphere. So when the instrument is ready to sample, we flush our manifold by opening the exhaust valve in intervals. When we're ready to take the sample inside of the canister, we send a command through our ground computer to open the solenoid valve, so the air will go through the solenoid valve that is open and draw the air inside of the canister.
So during a flight, we will collect at various intervals through the flight a total of 90 canisters through the flight, which is actually quite a lot for us to measure.
We have 90 canisters because that was the way that we need to set it up inside of the Global Hawks just for the space needs. And these are custom canisters of 1.3 liters. To get the air from the atmosphere, we use this manifold that is connected to an inlet outside of the aircraft. This one is our inlet when we draw the air and goes inside of the canisters. And the canisters are inside of the Area 61 on the aircraft.
Once the aircraft is on the ground, we remove our canisters from the aircraft and bring them to the laboratory. Laboratory, and what we see behind us is the analytical system that allows us to measure the chemical composition of the air in the canisters. Over here is starting from one side to the next, is the computer control that operates the system and stores the data that's generated by the analytical system. Next, we have our reference gases, which are used to compare, which are of known chemical composition, which we use to compare against our unknown samples that are collected on the aircraft. These gases, samples from these gases, are introduced into this system, which separates the very minor trace gases that we're interested in analyzing from the bulk of the air, which is nitrogen and oxygen. That's removed, and we collect the trace gases that we want to analyze in this system. Next, the mixture of gases which are collected on here are transferred by using heat to the gas chromatograph. The gas chromatograph separates this mixture of compounds into individual components over time. During the course of the analysis, as compounds are released from this mixture and separated in time, they go into different detectors. One of the detectors is a mass spectrometer, which is very specific for individual compounds that we can detect and know specifically what the compound is. We also use two other detectors, a flame ionization detector, which is sensitive just for hydrocarbon type compounds such as ethane, propane, light hydrocarbons, and also an electron capture detector, which is sensitive to a range of compounds that contain halogens, which is one of the groups of compounds that we're interested in analyzing. So we try to look at the amounts of chemicals in this region, and by looking at their distribution and amounts, we can say something about how fast these compounds are transported from the lower atmosphere into the stratosphere.